But yeah, so we're going to discuss microservices, the microservices architecture on the front end, to hopefully help us build applications at scale. So I'll say a little bit about myself first. My name is Jon Preece. I'm a front-end developer. I currently work at rental cars. I was a .NET dev for a long time, but I'm a front-end specialist now. And I am fairly active on GitHub. I do post on there quite a lot. I'm open to feedback, so if you've got any feedback on this presentation, please do let me know. The best way to get in touch with me is by email. My email's on the screen. So what specifically we're going to talk about tonight, the microservice architecture, how that can be applied to the front end, and a general overview of what microservice architecture is and what some of the benefits might be. We're going to talk about some of the tooling, some of the code, how you might want to structure your project. Hopefully we'll learn enough to be able to implement this pattern on our own repositories as we see how that goes. And we'll touch on one of my favourite topics, which is state management. Because when you're in a front-end microservice architecture environment, sharing state can be quite tricky. So we'll come up with some solutions to that. So see how this goes. I work at rental cars. This is the rental cars website. I work on the replatforming team. They are heavily invested in front-end microservice architecture. I was originally going to talk about this website today, because this is where I learned a lot about what I know. But I wanted to be able to give you a repo that you could go to. All, as you can imagine, all of rental cars code is private, it's closed source. So I wanted to be able to give you some code that you can look at later, and some code that implements everything that we've discussed today. So instead of talking specifically about rental cars website, we're going to talk. We're going to talk about this first. I've highlighted in here just to make you aware. There are several microservices running on this page that are not immediately obvious. The header, for example, is a microservice. The search box is a microservice. We'll get into that. So instead of talking specifically about the rental cars website, we're going to talk about this amazing, beautiful website that I've developed as a front-end dev. You may recognise it as a bootstrap template with a couple of images on it. But this is much easier to reason about and much easier to discuss. So, can anyone take a wild guess at where the microservices are on this page that are running right now? We've got one in the header, that's a microservice. We've got a Jumbotron, that's a microservice. We've got some results, listing information, which are microservices. We're going to talk about them. As I said, all this code is hosted on GitHub. There are actually 3 different code repositories. I really need to update that picture as well. There are 3 separate repositories. There's one called Buy My House API, which is the repository at the bottom there. And that is an application written in C#.NET that actually gets its information from Zoopla. It's got an API key, so it's Zoopla downloads some property information so we can display that on the site. That is a backend microservice. We've got Buy My House Gateway, which is it's basically a proxy layer that sits in between our front-end application and our back-end application. We're going to discuss why that's important as we go on. That's written in Node.js with GraphQL. And we've got the front-end repo, which is called Buy My House, which is a monorepo. It contains all our front-end microservices. So again, we're going to go into these in a lot more detail. But if you want to download this source yourself, it's all that. It's all open source. So going back to the title slide, I specifically said I want to talk how we can use front-end microservices to make apps at scale. So what do I mean by scale? I originally added this slide in as a joke. I can't remember what that joke was, but the more I thought about it, the more I realised that actually this is sort of appropriate because what we don't want to do is we don't want to build a really big, heavy, bulky application, front-end application. We want to break that up into constituent parts, which will be easier to manage, easier to deploy, so it's sort of appropriate. So yeah, of course, I'm talking about scalability. So how can we make our applications more scalable? So this is my super sophisticated project. And when I'm the only developer that's working on it, it's easy to maintain. I'm the only person that's contributing to it. I don't have any merge conflicts. I don't have deployment issues. It's just me. It's that easy. But let's say that the project's going really well, and company they're making loads of money and they hire more people, and you've now got 4 developers contributing to the repo, and everything's still manageable. It's still just about getting by. We're not getting problems with conflicts or anything like that. We've not got too many problems with deployment. But as always happens, the company gets bigger, the website becomes more successful, and they hire more people. And more people start contributing, and we start encountering these pain points of how do we resolve merge conflicts? How do we deploy our functionality out into the public? And this is a really successful company, so they've hired loads of people, and everyone's committed to this one repo, and it turns into a giant mess. So how can we make that better? Well, it seems obvious, but we can divide our project into several smaller projects, and this is your Frontend microservices. And so instead of having one monolithic repository or one big heavy project, we divide that into its individual pieces, and that becomes easier to manage from a project management perspective, from a delivery perspective, and yeah, everyone's happy. It's difficult to talk about scalability without talking about performance. We're not going to talk about performance right now, but we will talk about performance as we go along. What might be some benefits of microservice architecture? Well, I sort of touched on them a little bit, but if we're building smaller, more isolated applications, then they're easier to deploy. Small, independent, isolated, single-function modules with well-defined interfaces and operations. So our microservices, as long as they are well-defined and have a contract of operations and that contract is maintained, then we can build them in isolation and deploy them and not have to worry too much about breaking anybody else who relies on them. In traditional sort of microservice architecture, you would be able to scale your microservices sort of horizontally and vertically. It doesn't apply so much on the front end, but yeah, it's not so relevant on the front end because you don't generally need to scale your front end microservice architectures, but it's worth pointing out. We talked about deployment. If we can independently deploy our services, then that makes things like continuous delivery and deployment much easier. But because we've got a smaller surface area, we've got a lower risk, we've got a well-defined fallback strategy. Yeah. So the main sort of reason why people decide that they want a front-end microservice architecture is that they believe that they will be able to use different frameworks on each page, and we're going to get into that on the next slide. So going back to our amazing Biohouse website, if we take this screenshot and sort of turn it roughly into a diagram, so it becomes easy to reason about. So we've got this header component, we've got this menu component, we've got this footer component, and they're all written in React. So they're all isolated, they're all independent services. You may be wondering actually, if you ever use a tool like Webpack, if React is included on this page 3 times, because when you run your Webpack build, Webpack will pull in dependent libraries and generate you a vendor bundle. And actually, no, that's not the case. React will only be running on this page 1 time, because we can configure Webpack to do that. But this sort of architecture opens itself up to being able to use different frameworks for different components. So you may actually be able to write your header in Angular, or you may be able to write your menu in Vue. I don't think this makes sense. I think a lot of people think that this is the benefit of front-end microservice architecture, and I don't think that's quite right. I think when you might want to end up in a situation like this is when when you've got an application written in one framework and you want to migrate to another. So React is the hotness right now in front end world, but next year or next month or next week it won't be. It'll be something else. So this would make your deployment, your migration to that framework easier because you'll be able to migrate each individual component sort of on its own in isolation. Learn the lessons from doing that and roll out to the next one.
So how do you know which one to use? Which section? So like, how would you know to use Google?
We are going to touch on this a little bit as we go along, but you typically have an aggregation layer in the middle. The aggregator service, Microservice, would know based on some configuration somewhere, maybe from the database or from the text file or something like that, how to lay out that page, what components are going to go where. And this project that I've developed on GitHub, it doesn't have that layer. It's quite complicated, but yeah, we're going to. Back to this thing, performance. So this is roughly a typical like front-end application. Your front end may load, and it may have some initial data there already, but it may also need to go fetch some information from your microservices. It might need to get some information from the menu API, which goes out to AWS, maybe runs a Lambda function or something, or goes to an S3 bucket or whatever. And we may have to get something from header API, might have to go to a third-party API as well. It may be doing this on load, and that tends to be not so great for performance and not so great for usability. So in the case of the Trustpilot one, I may want to display, we actually did this. We actually did this around Scout. We may want to display some Trustpilot reviews to the user to say this is how our customers have rated this experience. And if we're doing that on load, then the user's got to wait for that information to download. That's going to affect that page load times. And it generally leads to not fantastic user experience. So when you're building front-end architected websites, it's often it's become the norm to introduce a gateway layer. So your front end will talk directly to the gateway, and the gateway will be responsible for fetching data from these services for you. What might be the benefits of having a gateway layer? You may be able to do things like server-side rendering. You may be able to server-side render your front-end application, which will improve things like SEO and improve perceived performance and page load times. This incidentally as well is probably the ideal place, in my opinion, to put something like GraphQL. So in this case, if we're talking to these 3 different endpoints, these 3 different APIs, then these services are potentially returning a lot of data back to us. We don't necessarily want to return all that back to the client because that might be expensive. Sending it over the wire, it might be slow. It might be a lot of data that we're not using. Like we might be downloading a huge array and then just using the length of the array, for example. I don't know. Like I've seen weird things.
Sometimes an API charges you, so if you can reduce the number of requests.
Absolutely, yeah, absolutely. Yeah, so I've seen a lot of people using tools like Apollo on the front end to do this, but I personally am not a huge fan of that. Apollo seems like a great library, but it's very much in flux. At the minute it's changing a lot. We've had a lot of breaking changes. So in my opinion, putting a tool like GraphQL on this gateway layer works better. That means I can just serve up the exact information to the front end. I don't need to worry about transferring data that's not complicated. So moving on to source control, what does this look like? So we've talked about all these different front-end microservices. We could potentially put them all in their own code repository on GitHub. There's nothing stopping us from doing that. They're all isolated, they all run independently, we just put them in their own repo. And that's fine when you've got a few, like 2 or 3 different repos, but as soon as you've got 5 different front-end services, or 10 different front-end services, or 50 front-end services, at rental cars we've got dozens, hundreds. And it's like, you can't put them all in the wrong repos because you will go crazy. Every time you want to work on a repo, you've got to pull it, you've got to do a yarn install or npm install, you've got to, you're going to be constantly switching windows in your editor, because you've probably got them all running in different windows and using loads of memory. And it all becomes a big crazy mess. So there is a potential solution to this problem. Yeah, well, in this case of the Buy My House repo, that would be the number of repos that we have. And this is a crazy simple application. You know, I've got a repo from the footer, my header, my web gateway, everything's got its own repo. And in an application this small, which literally has 2 pages, it's a lot of code. It's a lot of repos, a lot of code, it's a lot of cognitive load. So we've got this concept of a monorepo. Basically everything lives in one repo. That is a monorepo in a nutshell. When I first came across this, I thought it was bonkers. I thought, how can you put all your code in one repository? Like, isn't that going to be a monolithic application? The thing that we're trying to avoid. And the answer is no, because all of our microservices can be run independently and in isolation and just live all in the same place. So whilst we might have a bit of an initial, a bigger, when we're cloning the repository, the repo might be bigger, but everything is there in one place. Everything runs in isolation, or everything can be run together. So yeah, we have one single code repository. You may be wondering who is doing this. So big companies like Google, Facebook, Twitter, they're all using monorepos. That's actually where I first heard about it. Google, well known for having the biggest monorepo. And they've got literally dozens, hundreds of projects in there. I can't imagine how to make it work, but you do. So Babel released a tool to help with the management of monorepos. It's called Learner. I don't know if anybody's heard of Learner before. Yeah. And I couldn't help but show this slide. This is a screenshot of documentation from Babel's own Guild repo, and it discussed why they went down the monolithic repo approach. And I just think it's brilliant. So let's highlight some things that it says here. Juggling a multi-module project over multiple repos is like trying to teach a newborn baby how to ride a bike. So I've experienced this myself. You know, you've got code in several different places, and you can't. I was literally doing it the other day. Somebody asked me where some code was. I was looking in the wrong repo. I couldn't find it. I told them it had been deleted. So there's so much to remember when you've got code in all different places. This whole concept of monorepo is, they say it's taboo. I don't know if it is. Has anybody here worked on a monorepo before? And it's done, right? It's putting on projects in. This is on there. You can see this on the Cut today. They question whether it's a double decision, but no, because everyone's doing it now. It's cool. React's doing it. Ember doing it. It's all cool. I didn't believe it actually. I went to the React repo, had a look, and I was like, yeah, everything's there. React scripts is there. React itself, React DOM, all the main libraries that make up React are all there, present in one single repository. So going back to the Buy My House project that we saw earlier, I mentioned it was a monorepo. What does that look like? Well, we have this folder, packages. There's no actual code at the root level of the project. There's just package JSON file, a bit of configuration for linters and stuff. There's no actual any code there. To see the code for the application, you have to go into the packages folder, which is where all of our front-end microservices live. We've got our footer, our header, our listing, our shell, which is the replacement for the aggregator in this project. And the shell just has dependencies on everything else, and brings them in and builds a page based on that. So what does each individual package look like? Well, it just contains a package JSON and the actual code, so that this project can run entirely in isolation. If I wanted to publish this repo, this shell as a repo to npm, then I could do that. There's nothing stopping me from doing that. If I wanted to break it out of the mono repo and publish it in isolation, I wouldn't have to do anything. All the code is already there, so for it. So when I showed a screenshot earlier on the Buy My House application, we had the header, the jumbotron, we had a listing of properties and stuff. With this approach, I can actually run any of those things in isolation and develop it in isolation. And we found that to be a huge time saver at rental cars, because spinning up somebody's pages and making a change and running it through Webpack is so slow. Like, it's crazy slow. It takes minutes because there's so much code, so much SAS to process. Yeah, to be able to run the components in isolation like this significantly reduces the amount of time that it takes to get my code change on the screen. And we're talking going from minutes to seconds. So I want to touch on tooling a little bit. I've already briefly mentioned Learner for doing package management. We're going to dive into that a little bit. Yarn workspaces combined with Flownet is amazing. That's a quote from me right now. I just had it. Anybody use Yarn? Anybody not know what Yarn is? Yes, Yarn is a lot like npm in that it can install your packages and manage your packages for you. Yarn has the reason why we use Yarn at Enterprise basically is that it has this feature called workspaces. And what this allows is it allows us to run yarn install one time for our repo, and it will install the node modules for every single package in that repo. And also it's smart in the way that it works. It doesn't just go into each package and install the dependencies. It hoists them up to the root level. So I only have one single node modules folder in my workspace, which is great. I can only imagine the hundreds of millions of megabytes it would take to install modules in every package. So typically when you're working with monorepos, you're going to be using Yarn. As far as I know, there is no comparable feature in NPM. I'm sure, undoubtedly sure, that they will come at some point in the future. I just don't know when that is. So yeah, Yarn and Learner are the best friends. You're probably not going to use Learner without using Yarn. So, my favourite topic. I presented it on this. Each of these slides could easily be a whole chat on their own. This is a 10,000 foot view that I'm giving you. And I've previously done talks on State, so we're diving into talk. We're diving into State a little bit and discuss how we solve the problem of State in rental cars. So we probably don't want applications to live in isolation. We're probably at some point going to want to share State. We're going to want to communicate with the outside world. He's isolated on a planet. He probably wants to talk to a different planet. That's going to happen eventually. You're going to need some sort of tool for that. Don't worry too much of fancy code. It's not really super important. But what we did rental cars to solve this problem is we basically developed a light wrapper around Context API. And what that does, effectively what that does is it sits all our state on the window. And this is basically how Redux works. A tool like Redux. We've taken some inspiration from Redux and used a window. And it's every time that one of our microservices wants to communicate that some state has changed, it calls an update state function, which we expose to it. And the window, the global state is updated. Each microservice listens for that state change and then tries to re-render itself. As we all now virtual DOM experts, we know that React it has virtual DOM diffing built in. So when our global state changes, we call set state, which triggers a virtual DOM diff, and React figures out whether it actually needs to re-render anything. So we found we put together some sample tests on this project, and we've run a dozen microservices on a page at once, and we haven't noticed any particular issue with performance. We're calling set state in this way. So it's actually plugin code, but don't matter for this to happen. So I begin to wrap up. Well, before we carry on, I wanted to point out to you something that was on the tech radar recently, the ThoughtWorks tech radar. And this has been on in the past, but it's re-emerged recently. I think it was in last edition. And it talked about this concept of microservice envy. So just because everyone else is doing microservices doesn't mean you should. Basically, is what they said. So if you're thinking about creating a front-end microservice architecture, then you need to make sure that it's right for your project first. It's probably not for everybody. We made it work at rental cars, and it's something that I would definitely consider using in the future. But I think it largely depends on your application and the state of the application. I think if I was developing a greenfield project, I would seriously consider using it going forward. I'm not sure how easy it is to work into an existing project. One of the limitations of Learner that I didn't actually mention was that everything has to be a package, and if it's not, it doesn't work. Ask me how I know. Because I literally created my shell application outside of the packages folder and it didn't work. And it took a whole week to figure out why not. So yeah, everything has to be a package. So if you've got a big, well-established front-end application, then you can't just migrate it piece by piece, slowly over time. And it doesn't seem to work. So really, it's best suited, I think, for greenfield applications. So what are some of the pros of front-end applications? We've sort of touched on plenty of them as we've gone along. But smaller modules are faster and easier to release. They're easier to understand and easier to onboard new team members because there's less code to look at, there's less cognitive overload. You can reuse your microservices in many places. So again, if you've got an aggregator layer, you can use because you know that your service is isolated, you can use that anywhere on a page, you can use it on any page. They're very reusable. There's less to roll back when things go wrong. Things will go wrong. So if you've only got one component to roll back, that's easier. And yeah, we talked about the ability to be able to evolve microservices over time and make changes to change the framework. It can go in a whole different direction on their own. As long as they maintain their contract with the outside world, then you can do what you want, basically. Cons, are there any drawbacks to front-end microservice architecture? Well, sort of. There's the potentially increased DevOps if you've got something like a migrated service. There could be more monitoring. There could be the need to integrate CI/CD tooling so that you can deploy your services easier and quicker. You may have to utilize tools like Graphite and Grafana, but you probably should be using them anyway, regardless of using a front-end microservice architecture. There typically is increased configuration, so we talked about configuring Learner. There's some caveats, there's some changes you have to make to Babel to make it work properly. Yeah. And your applications do tend to be chattier in terms of they do tend to make a lot more extra requests to backend services, although we have discussed how that can be mitigated. So to summarize, front-end microservice architecture, break your front-end in smaller pieces, which can be independently iterated, deployed, and managed. Introduce a web gateway to reduce chatter and improve performance, like GraphQL. You put all your components into a SQL repo, called a monorepo, and you'll need some sort of solution to change state. Because whilst we seriously looked at using Redux rental cars, but because of the stigma around using a tool like Redux these days, it just didn't seem like the right solution that we wanted going forward. So there doesn't seem to be a really good open source solution right now to sharing state between your microservices. So you may need to do it with Fugitive and Molinar. So a bit of work required there. And that's it. Thank you.